I would like to now introduce the next speaker. It's Magnus Östberg. Welcome on the stage, Magnus. Magnus Östberg is Chief Software Officer at Mercedes-Benz from 2021 on. Before he was with Aptiv and Delphi, also in the field of software. And Magnus, you're going to introduce MB.OS, chip-to-cloud architecture for a luxury experience.
Thank you very much.
We're excited to hear that.
Excited to be here. Thank you very much. Thank you.
Please go ahead.
Thank you. Clicker here?
Yes.
All right, thank you. Well, thank you very much for having me, and excited to be back here as a speaker. Visited this event many times as a supplier, as you heard from my resume. And so what I'll speak about a little bit, giving a little bit of context of what the previous two speakers have talked about, and what I believe that we should concentrate on as an industry going forward. But before I get to that, I want to give a little bit of a context, since everybody is not up to date on what we define as our software-defined vehicle. The name that we have chosen for our software-defined vehicle is MB.OS. It's a chip-to-cloud architecture that is aimed to decouple software from hardware in order to accelerate our pace of innovation and accelerate the number of features that we can offer to our customers. How are we going about doing that? Well, the way we're going about doing it is really to take control of the architecture and not trying to invent everything again, not inventing the wheel, but to integrate partners as quickly and efficiently as possible. But in order to do that, we believe that we need to own the design and the architecture, and most importantly, the integration capabilities in order for us to integrate and accelerate. So what does that mean? Practically? Well, practically what it means is that we are basically using what we call an architecture. In this case, we have chosen to visualize that in terms of a physical architecture, building a house in order to give some clear understandings. What we have done then pragmatically is that we have designed a footprint that we're building on. This is a domain architecture. Domain architecture is basically 2 computers supported by 3 additional in order to provide us with the connectivity and provide us with the interface to the rest of the vehicles. But most importantly is that we are sourcing and defining the components of this standardized sourcing directly from the chip suppliers directly in order for us to facilitate the overlying then software architecture on top of that. So where are we? We have today launched pieces of this already in our E-Class. Our E-Class that was launched previously this year, we've already put this in motion. So basically making sure that this is an architecture that is connected to the cloud and it's on the way to being fully launched into the vehicle. Just to give you a little idea then what we can do before I get into these examples, I give you a little bit of a taste what the E-Class offering to our customers today and how that looks for the end user. So, because that is, of course, at the end of the day, what we are about as a company, to create this luxury experience to the customer, enabling them to integrate into the digital ecosystem. All right, so what you saw there was really our architecture that is there in order to build an infrastructure to the entire vehicle interface. So ultimately, the customer wants to get into a Mercedes and want to experience, of course, a luxurious environment to sit in, but also to experience a luxurious digital environment with a rich content. We heard about previously how quickly our competitors, the pure BEV companies, either from the west coast of the US or the east of China, how quickly they are integrating and delivering these services. And we believe that we need to offer this speed of innovation at the same pace, plus the traditional experience from a Mercedes-Benz car to provide that luxury experience. That combination is what we believe is unique and what we're striving for. And in order to do so, we need this control over this architecture, because otherwise we are not going to keep up to do what Dominic talked about previously. The only way that we could integrate ChatGPT at the speed that we did was because we had control of the interface to the cloud, the APIs, and how to hook that into the existing infrastructure in the vehicle. With that is a concrete example of the speed that I'm talking about and why we are doing it. But we cannot stop here. The evolution is going forward. We just heard from Dominic. We'll hear from many, many more here what new technologies are coming very quickly then into the market. So therefore, we are looking then, of course, to integrate even further domains into further areas of our system in order to give a more holistic experience. So what we have built so far, and we've already launched that right now, is of course is based on the standard interfaces to the vehicle. And I'm not going to preach about just the way that we have done it, but this is here to illustrate the principle and to build up to my recommendation, or at least our focus where we want to go when it comes to standardization. So we have, I think, on a good basis, have a successful cooperation with our basic communication needs that we need across all of these 4 domains. In order to set it up, the AutoStart Classic is a well-structured and standardized communication layer that we have developed our basic communication need together with Vector. That is, of course, enabling rest of the industry also to leverage this, go to Vector if that is something that is of interest in you. But when we're now moving away from the microcontroller space and really going to the SoC space, we're coming into areas where we have been doing our own standardization, but what I will get to is that we are really interested in looking at an industry standardization when it comes to these additional services that we need when we're coming to a central compute. Now, regardless if you are now placing Android apps on top of this, or your customized apps on top of this, or other types of embedded third-party applications, which basically the ChatGPT is one example of that. This is a combination of cloud-based services combined with the capabilities that we have inside of the vehicles. That is the reason that we're having this architecture in order to build this kind of services for our customers. And the entire stack that we have now put in place together with lots of partners, Microsoft being one of them, of course having Android components in that as well, is really to be able to launch this with our new CLA, our new MMA platform, which is coming out end of next year. Now, what are we going to do with all this first version of our MBUS that we are now getting ready to launch? Well, we believe that a large portion of what we have developed can be reused. And we have launched an initiative, and we're going to host our Free and Open Software Conference in November at the Mercedes-Benz Museum. So if you have time, please join us for this initiative. There are some spots left in order to have an honest discussion about what is our contribution so far, where can we contribute more, and where are others going to be willing to contribute to our the common open source repository. So open source for us is going to be one of the key, and I'm really looking forward to the panel discussion here after the coffee break to hear more about the insights about how we can further elaborate and further accelerate the use of open source in not only our operating system but also in others. Now, coming to the area where I am going to go into where we're going next. So of course we're going to roll this 1.0 version out into lots of vehicles after the CLA. But most importantly, where is the industry going? And I believe my colleague from BMW is going to talk later on about the step away from domain architecture into zonal architecture. We see this trend, of course, as well at Mercedes-Benz. Going into a central compute is very key. But most importantly, what is important for us is to really look at how are we going to accelerate. acceleration not only in terms of bringing in new services, because Microsoft, Google's, and the others are bringing in out new services in a very rapid pace. And of course, we want to take advantage of that using development speeds and tools. But one of the key questions that has come to our table right now is the fact that once we are now moving from a domain architecture to a centralized compute architecture, we're abstracting away the actuators and sensors from being connected to the domain controllers. Having then a central compute is giving us a lot of flexibility that is traditional capabilities for the auto industry. So of course we're reducing packaging, and that gives us better range, that gives us better possibilities to control complexity when it comes to the manufacturing. But most importantly, it gives us a possibility to centralize all of the services in one physical locations, in one compute. However, there are then lots of new software challenges that we need to look at. And one of them for us is to standardize APIs across domains. Today, the autonomous driving domain and the infotainment domain and the body domain are quite different when it comes to how the APIs and how the services are set up. Having that coming into under one roof gives us quite some interesting challenges. And the challenge that I have chosen to describe it here, I have chosen to visualize it in two areas. One of them is from a pure services perspective. Looking at the top-level services that is either in the vehicle or outside of the vehicle in the cloud, they require a functional service abstraction standard. What do I mean with that? Functional service. So a service wants to do something in the vehicle, and if you're looking at across the domains, today we don't have a standard API or standard setup for that. That is one of the challenges. The other challenge is what I mentioned before. When we move from a domain or a embedded world into a SoC world or a central compute world, we have some basic communication needs that is not standardized today. So if I go into these two areas where I believe there is a great benefit for us in order to increase the speed and increase our possibility to collaborate with others, I believe that is in these two areas. So let me start with the first one, the functional service abstraction layer. What do I mean with that? Well, basically, just providing information to the outside world in that kind of architecture. So an abstracted sensor, regardless how you have implemented it, how anyone has implemented it, to provide that kind of interface, that kind of API to the vehicle about the temperature sensors in this example, or in the other direction, how to make sure that certain actuations are being performed. This is what I call a functional service API. And regardless if then the implementation has been done using Android or has been done using Linux or has been done using QNX or any of the combination of services, this type of APIs, this kind of functions is something that that we see it there. And one of the standardization bodies that we have decided now to contribute to and work in order to help to create this standardization vehicle service catalog is Covesa. So in this area, I believe that type of interface, that type of body can really help us on that. There are lots of things that Covesa has done in the past or doing that is going much deeper, but I believe that this vehicle service catalog is a need for us, and this is where we have decided to go in and really work on standardizing this service interface. So that is the first example. The second piece, or the second area of standardization where I believe that we really can help and accelerate would be basically in the central compute. And what do I mean there? Well, I'm talking about the non-differentiating items that doesn't differentiate if we have an Opel or BMW or a Mercedes or anybody else. Our customers are not buying our car because we have the best software update or flash process. They're not buying our cars because we have the best diagnostics capabilities and not because our safety, well, you can argue safety is a vague word. You can argue different levels of safety, but basically if you talk about cybersecurity, we all need to live up to the new standards. So that combined with the data analytics that we need and the virtual target definitions that comes out of the data acquisitions. Here I believe we have a big possibility to standardize and really to come to a situation where if we're focusing on basically the non-differentiating aspect of that and not getting lost in defining the entire stack, not getting lost in arguing if one real-time operating system, Linux, Android, QNX is better than the other, but really looking at the items where we can have a meaningful improvement of speed of development in this industry. I think we, as the Western world OEMs and also the traditional OEMs, have a really chance to stop wasting time in areas that doesn't make my car any better than anybody else's car. So that's my pitch today. So with that as a takeaway, I would like to say let's join and set the path future for the industry. And I'm really looking forward to the discussions to see if you have different opinions and if you have different aspects. But this is my opinion and the company, the opinion of Mercedes-Benz. So let's kick off the discussion and have a fruitful exchange dialogue here today. Thank you very much.
Thanks very much, Magnus, for this great overview on MB.OS. I think I liked your notion of chip to cloud. Others call it end-to-end, but I think it's something similar. You talked about the control of interfaces and also managing integration to become fast and successful, for example, integrating ChatGPT. Would you be willing to discuss the opening of these interfaces in terms of free and open software? Is that something that's on your mind, or does it have a full stop somewhere where it comes to, let me say, OEM-specific functionality?
How exactly the end customers are experiencing it, meaning having I like the definition here where it's not just a voice interface or a human interface, it's really this interface to the customer. We believe that this is something that needs to be unique, at least to a brand like Mercedes-Benz. So this is a full stop for me, that having control of how the customer is experiencing it and how we are then having that dialogue with the customer, this is something that I believe is differentiating. So this is something that is proprietary. However, how we enable this, how we go about doing it, what is the underlying functionality, meaning how we tie in partners, how we collaborate in the industry for the non-differentiating items. Here I am completely willing, and we're doing the actions right now with the FOSS initiative to contribute with the pieces that really, I don't believe there is any benefit for me to keep doing what we're doing, and I would love to use and take open source component in these areas.
Now, you had some examples in your presentation, these lines of diagnosis and safety and so on. Are those the categories that you see as candidates for open software then?
Yes, I do.
Okay, great. Magnus, thanks a whole lot again. It was an honor to have you here, and have a great conference.
Thank you. Looking forward to it. Thank you.